Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the periodic table basics, the atomic number, and the atomic mass basics. So the periodic table is a way for chemists to organize the different elements found in nature. And we have groups that go down, and then the periods go left and right in rows. So the groups are columns, and your periods are your rows. The groups are based on chemical properties, and they have their names that are associated with them. You really only need to know the ones that are asterisks, the alkali metals that form compounds with oxygen that when you dissolve them in water, they're very alkaline or very basic. And then alkali earth metals have that similar property, but they're found in the ground, in the earth, so they're called alkali earth metals. And then the halogens we'll use a lot throughout chemistry and organic chemistry and everything else if you take further chemistry classes. But they form acids, binary acids, when they form a bond with hydrogen. But these are all the different ones. And then in the middle here we have the transition metals. In this area here, let me highlight that a different color. In this rough area, okay, so your transition metals. And then everything to the left of this, I'm sorry, to the right of this imaginary barrier, roughly, these are going to be your nonmetals. And here we're going to have a couple series that are off the periodic table themselves, the actinide and the lanthanide series. And this is just a rough video of the basic concepts. We're not going to delve too much into them, just know that they're there. So the periods, they share the same quantum shell. If you remember the electrons, they orbit the nucleus in these spherical shells of probability where you might find an electron or electron densities. Well, the rows are the same periods, the same quantum number. The way we organize this periodic table is by using the atomic number. And the atomic number, basically what it is the number of protons. So hydrogen has 1 proton, helium has 2, and then so forth and so on as you go further down and across to the right of the periodic table. Another little fact is that the number of protons is also equal to the number of electrons in a element. So that atomic number also allows us to figure out not only the protons but the electrons. Then the atomic mass is the average mass in AMUs of the different isotopes that you find in nature. What happens is an isotope is a slightly different version of the atom that has a slightly different atomic mass. So basically it differs because of the number of neutrons. So in nature you have chlorine, for instance, 2 different isotopes, and that mass of, I think it's 35.43 or something like that, that you find on the 453 maybe, on the chlorine or on the periodic table, that's an average of the 2 isotopes that you find in table salt. Or iron has 4 isotopes. I don't know what the mass on the periodic table. Let's see what it is. Iron is 55.845. That's the average of the 4 naturally occurring isotopes in nature. So if you look at the periodic table, each element will have an atomic number that's found at the top. Here, I need to make my size a little bit smaller. It's too big. So when you see an element on your periodic table, like carbon, for instance, carbon has an exact mass of 12.0107, and you'll see that down here. 0107. And you will see the atomic number of carbon, which is 6, above it. Okay, so this is the number, and this is the mass. And that mass being the average of all the different isotopes that occur in nature. Okay, so I'll go through the different videos, example videos of how to find protons, electrons, for ions as well as for neutral elements. Ions are just created when you lose or gain an electron, and we'll talk about